Okay, so let's have a look at the polar form of a complex number. So the first thing I'm going to do is just draw the complex plane. So we're going to have our, let's say, y-axis or our imaginary axis. Our x-axis is going to be our real axis. So this is our real axis here. This is our imaginary axis here. So let's say we have a complex number that is, let's say, here. The position of that complex number then is going to be x plus yi. So in other words, we need to come out along here, x, and go up along this distance, y. But we can define the position of that complex number in polar terms. So what we would need is the angle here, we'll call it theta, and the distance from the origin, r. Now theta is the angle that the complex number, the line joining the complex number to the origin, makes with the positive sense of the real axis. We would call theta the argument. It's called the argument, or just a or g of z. Let's say this is this complex number here, we'll call it z. The argument of z then is theta. So if you look at theta, then we can say that the sine of theta is y over r, which will just give us r sine theta is equal to y by just multiplying across by r. Similarly, we can say that the cosine, the cos of theta, is x over r, or cos theta is equal to x. So we can substitute r cos theta for x and r sine theta for y into our rectangular form. This is called the rectangular form here of our complex number. So in other words, we can say that x plus yi is equal to x is r cos theta plus, we will put the I first, and then the y is r sine theta. So all we've got to do then is just factorize out the r's. So we've got r cos theta plus I sine theta. This is our rectangular form on the left-hand side, and this is our polar form on the right-hand side of our complex number. The other thing you've got to remember here is that our theta has to be between minus pi and plus pi. When you're writing a complex number in polar form, these values here have to be between minus pi and plus pi. Okay, so what I want to do next is just look at four complex numbers. Each complex number is in a different quadrant, and we're going to convert them to polar form. So the first one I'm going to do, this is number 1 here, so the first one I'm going to do is 2 plus 2i. So let's have a look at that. Let's convert that to polar form. So what I would normally do is just draw a quick sketch to show where exactly it is on our complex plane. So this is our real, this is our imaginary axis. 2 plus 2i is going to be, let's say here, 2 plus 2i. If we look at this, we can see that we need to go out 2 and up 2. This is going to be our theta here, and this is going to be r here. So let's first of all look at the distance, or the distance that the complex number is from the origin. This is just simply a case of Pythagoras' theorem. So really r is just going to be the square root of this squared plus this squared. So it's going to be 2 squared plus 2 squared. So that is 2 2s are 4, 2 2s are 4, that's the square root of 8, which is 2 root 2. So that's going to be our r, the distance from the origin. Now the next thing we've got to do is work out what our angle is, what our argument is. And the way we're going to do that is use tan. We're going to say the tan of theta is equal to 2 over 2. You can see it's opposite over adjacent. That's just equal to 1. So that means the tan inverse of 1, or the arctan of 1, is just 45 degrees, or we're going to stick to radians here, so that's just going to be pi over 4. So that's our argument. So we just need to write 2 plus 2i then in polar form. It's going to be r cos theta, so it's going to be 2 root 2 cosine pi over 4 plus I sine pi over 4. And that's it for our first complex number in the first quadrant. Okay, so let's have a look at our second complex number. So this is the second one. So this is going to be minus 1 plus root 3i. So first thing I'm going to do is just draw a quick sketch of where it is on the complex plane here. Again, this is our real axis, this is our imaginary axis. So it's minus 1 plus root 3. So that's going to be in the second quadrant, it's going to be out here somewhere. So let's have a look at this triangle here. Now we can see that we go out a distance of 1. It's actually minus 1, but the actual distance is 1. This is going to be root 3 here, and this is going to be r. Now I'm going to call this here alpha. This is going to be my reference angle, and theta, which is what we're actually looking for here, is this angle here. So from here to here, that's going to be our theta. Okay, so let's go and find r first. So r is going to be the square root of minus 1 squared plus root 3 squared. So it's this squared plus this squared here. Now if you work that out, let's see, you've got minus 1 squared, which is 1, root 3 squared, which is 3, 3 plus 1 is 4, square root of 4, 2. So our modulus is 2. The next thing we want to do is work out the angle alpha here. The way we're going to work out alpha is look at tan. So we're going to look at the tan of alpha, which is root 3 over 1, or just root 3. Now the tan of 60 degrees, or pi over 3, is going to be alpha. So in other words, what we're going to do is say tan inverse root 3 is going to be pi over 3. In other words, our alpha, our reference angle alpha is pi over 3. But we don't want alpha, we want theta. So how are we going to work out what theta is? So let's have a look at that then. Well, theta is this angle here. We've worked out that this is pi over 3 here. Now you know that if you go from here to here, 180 degrees, that's pi. But another way of writing pi in terms of the denominator being 3 is just going to be 3 pi over 3, which is just the same as pi. Now we want to go back 1 pi over 3, so our theta is actually 2 pi over 3. So I can say here theta then is going to be 2 pi over 3. So that's it really. We have the or, we have our argument, so all we've got to do now is just write out minus 1 plus root 3i in polar form. So I can say minus 1 plus root 3i is equal to or, which is 2 cos 2 pi over 3 plus I sine 2 pi over 3. And that's it. That's that complex number in polar form. Okay, so let's look at our third complex number. So our third complex number then is, this is number 3 here, so our third complex number is minus a half minus root 3 over 2i. So first thing again we're going to do is just draw it, or sketch it I should say. So let's see, it's going to be in the third quadrant, so it's going to be down here somewhere. So we're going to look at this triangle here. Now you can see that we're coming out here a half, it's minus a half, but the actual distance is a half. We're coming down along here, root 3 over 2. This is going to be r here, and our theta is going to, in this case, be this angle here. It's going to be a negative angle. So remember, theta has to be between minus pi and plus pi, so we've got to use our negative angle here. Now our reference angle again is going to be this angle here. So let's work out alpha first. Well, actually what we'll do is we'll work out r first. So we're going to do r first. So r again is just going to be the square root of minus a half to be squared plus minus root 3 over 2 squared. If you do that, you'll just get 1. A half squared is a quarter. Root 3 squared is 3. 2 squared is 4. So you get 3 quarters plus 1 quarter, which is 1. So the square root of 1 is 1. So our r is 1, and what we got to do next is just work out alpha and then subsequently theta. So let's do that. So we're going to work out alpha first. So the way we're going to do that again is tan. So we're going to do the tan of alpha is equal to the opposite, which is root 3 over 2, divided by the adjacent, which is a half. So that's just root 3 over 2 times 2 over 1, which is root 3. These two just cancel here. Okay, so we have tan of alpha is equal to root 3, so tan inverse root 3 then will give us our alpha. So our alpha then is just going to be 60 degrees, or in radians it's going to be pi over 3. So we got pi over 3 is our alpha. Okay, so now we've got to work out theta. So again, if you look from here to here is going to be pi. So in terms of a denominator of 3 there, pi, another way of writing pi would be 3 pi over 3. So that's from here to here. So we've got to go back 1 pi over 3. So it's that just means our theta then, is just going to be minus 2 pi over 3. Okay, so now we can write out our complex number. So remember, it was minus a half minus root 3 over 2i. So our modulus was 1, so it's going to be 1 cos minus 2 pi over 3 plus I sine minus 2 pi over 3. And that's it. That's our polar form of our complex number. Okay, so let's look at our final complex number. So this is number 4. And this complex number is 2 root 3 minus 2i. So again, let's just quickly sketch it. So real and an imaginary axis. So this is in the 4th quadrant. So it's going to be down here. So again, let's look at this triangle here. Now, again, our reference angle is here. Our R is here. Remember, we're going out 2 root 3 to the right, so that's 2 root 3 out there, and then we're going down 2 units. Now, in this particular case, theta is just going to be this angle here. So it's going to be the same as our reference angle. Now, let's just work out the modulus first. So R is equal to the square root of 2 root 3 squared plus 2 squared. So if you do that, here you'll get 2 2s are 4, 3 4s are 12, plus 4 16. The square root of 16 is 4. So our modulus here is 4. Now let's work out alpha. So we want the tan of alpha is equal to the opposite, which is 2. The adjacent is 2 root 3. So our tan of alpha is 1 over root 3. Our tan of alpha is 1 over root 3, so we want tan inverse 1 over root 3. That will give us our alpha. So the tan inverse of 1 over root 3 is going to be pi over 6. So alpha is just going to be pi over 6. Now theta then is going to be minus pi over 6. Remember, we're going in the clockwise direction, so therefore we're looking at negative angles. So our theta then is just going to be, that just implies theta is equal to minus pi over 6. So again, we have our modulus, we have our argument, so all we've got to do is write out the polar form of our complex number. So we had 2 root 3 minus 2i, so that's equal to 4 cos minus pi over 6 plus I sine minus pi over 6. And that's it. In fact, that's it for this video.